Hello? 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 Okay, so this is the first lecture for comp9318, data warehousing and data mining. So what we are going to do is that to give you a quick introduction, and I'm going also to demonstrate something on the Python notebook. Let me find out, okay, which one is, okay. Hello? Okay. Hello? Okay, so then, then we actually do a quick introduction, and we probably go through some kind of examples to give you some quick idea of the things you are going to learn in this course. So first of all, everything you need to know is actually on this web page. So basically, it's the usual CSE URL prefix. This is the course name, CS9318. You don't really need to type the rest of them. You just type in this one, it directly goes to the homepage. So all the announcement will be here. We are also going to use the forum called Piazza. So once you register, you should be able to receive notification there as well. And I'm going to put on more information when they are available throughout the course. And yeah, we'll cover this later. So the lecture time is today from 6 to 9, and in this theater. For all the course notes, I should be able to put it over the weekend. So basically before the course, the lecture. So it's in PDF form. And I might do some kind of modification later. And if that's the case, I'll put some update sign there so you know some slides are updated. I'm also going to upload other accessory notes as well. We are actually also going to use a lot of Python, and we are going to use the excellent tool within the Python ecosystem called the Jupyter Notebook. So the best way is that you actually install Git, and you pull the repository from our course repositories. All you need to do is to just do this once, and every time you, we probably will put in a few. So we actually putting all the notebooks currently we have there, and we probably will be adding a few more. So if you need updates, you just use git pull again. Okay. So let's quickly go through the course info. So probably let me see. Probably I do it. Okay, probably we just go with the Okay, so this is my contact information and my homepage. My office is in the CSC building. It's on the level, 5th level. It's not in the lab area, so just in case you need to find my office. So basically, I'm doing a bunch of research in. Recently, we actually are doing quite a lot in natural language processing, and in order to construct a knowledge graph. I'm also doing high-dimensional data and the similarity query processing, and so the other more new direction is to integrate AI techniques with data management techniques. So as I said, the course homepage is there, and we're going to use Piazza Forum as the main form of communication. So currently it's set up, but you can't enroll. So by week 1, I do expect some people will actually drop the course, and some new people, actually quite a few are on the waiting list. So after week 1, I'll enroll you, all the current registered students, all into the forum. So that's the plan. So my own email is weiw@csc, but I do highly suggest that we try to resolve the matters over the Piazza, especially for course-related contents. Only if you really need some kind of meeting in person and or discuss some kind of personal situation, which will be solved easily in person, you can send me an email. But again, I'll try my best to respond as soon as possible, but it's often several days of delay. So unfortunately, I'm really heavily overloaded. Got not only this kind of teaching, and also a large bunch of research projects to do. Okay, so the lectures are from 6 to 9 in this theater. So we do not really have people, tutors to do tutorial in the labs. It's actually my belief that you guys should learn by yourself. We actually hold these kind of things in the past, but especially for 9318, many people I mean, currently maybe the percentage of students working full-time and taking this course after work versus those students doing full-time study mode have changed. But in the past, quite a lot of students are actually working full-time. So, and unfortunately, we can only arrange lab and tutorial in the daytime. So basically, the attendance is low and it doesn't really work. And also, you can see that I think the general trend is that we actually put all the material there, and we really encourage you guys to participate in the forum. Sometimes you can actually do a discussion, and even if you can, for example, if you understand some points and you can explain your understanding, don't be shy. Actually, later I'll mention that your own understanding is very important. That's actually much more important than the so-called gold knowledge, or let's say these formulas. These are actually absolutely useless. Okay, these are other people's knowledge or ideas. You really need to get your own. So basically, all these kind of, especially with the Python notebook and sort of like the major contents of the course, you really should try to learn by yourself. And go through the tutorials and labs by yourself. And if there are any difficulties, if there are some kind of common problem, we can actually arrange alternative measures as well. Okay. For consultations, again, we try to do this everything online. Basically, if you really need something to discuss with me, you can send an email to me to make an appointment. So about the assessment. So the course have one written assignment. So written means it's more like I'll give you some kind of test description of the problems, and you need to work out the solution. It could be related to algorithm. It could related to asking about what's the final output of, let's say, running this algorithm on this problem set. And it could also be trying to prove something, or asking why we need to do this kind of things. Or let's say the algorithm is assume, okay, the data, let's say it's uniform distributed, and what if the problem instance we have is slightly different, right? So you need to sort of like use your understanding, trying to do something new. And there is actually a major programming project. We are still developing it, but probably, most likely it's going to be something called adversarial machine learning. So again, we are not doing deep learning because it's not a deep learning course. But if you are into deep learning, basically this is a concept, I think, phenomenon spotted back in 2013. And so basically there has been a lot of research since 2016. So it's one of the hottest research area in deep learning. And again, we are not doing deep learning, but the concept still applies for the traditional classifiers we are going to talk about. So we are going to do something on that one. We also have lab, and currently I think we will have 5 labs. So the lab, actually we have a special online submission system. It's all in Python. So you are going to implement some kind of functions, and we'll tell you, okay, how to call the functions, and we probably will call the function on different kind of data sets, and we try to see if you get the implementation right. Basically, the good thing is that you can submit many times before the deadline. Okay. But again, be gentle to our server. So it's all our research machines. So you can basically get immediate marks back. The best thing is that we can only give you some kind of, some students call it vague feedbacks because we simply cannot show all the program trace. So we probably will use some kind of rules to say, okay, these are the common type of things you probably want to check. So basically, the feedback is kind of limited, but again, on your side, you definitely can, if you understand the algorithm or understand how the function works, you can actually, let's say, even implement a naive algorithm, or just by hand, you can actually know what's the output, and you are strongly suggest to test locally, right? That's one of the basic skills for any of the programmers. So basically, for all these kind of labs, it's up. So you only need to do. I mean, if you only want to do minimum job, you only need to do 3 of them, because essentially we look at your scores and take the largest 3 and do the average. Okay. So again, for example, if you really tried lab 1, 2, 3, and for some reason, I mean, you didn't get a satisfactory score, so there are still 2 more chances, right? Again, if your goal is not really to get a mark, but try to learn something, you are more than welcome to try all the labs, right? So if you really got 100 in first 3 labs, it doesn't matter. I mean, even if you didn't get it right for the later 2, it doesn't affect your score, right? So that's like a safety measure. So for the labs, we probably don't allow any late penalties. Again, this is because we actually allow you to try many times. You got a lot of feedbacks. And in the past, again, all these kind of lab exercises, later when we have the lab, we'll explain more. But we are not really trying to trick you guys. So don't worry about too much about, for example, if the input is an array, I pass some non-object to you. So basically empty array. Empty array and non-object are different, but you don't really need to do a lot of stupid checking, right? But of course, I mean, if you are really developing like industrial strength code, you really need to check the boundary conditions. So if you got anything wrong, it's most likely the algorithm and your understanding of the algorithm, or even what you are supposed to do in this scenario, rather than, you know, we try a very tricky case to really give you a hard time. So all these kind of labs, suppose, are actually encouraging you guys to get your hands dirty. So that's really what I really want to see, because many of after you learn all these kind of theories and algorithms, it doesn't automatically give you enough credits or experience to really tackle some real world issues or problems. A close analogy is programming language, right? So you can learn C, Java, or Scala, or Haskell, whatever, this kind of popular languages. You can know all the syntax. You can even pass all the exams, but if you do not really have a lot of programming experience, as long as you write any reasonably large project, you will actually find that you either end up with a very bad code quality and a lot of bugs, or even very, very hard to do it right. Okay, so you really need to learn a lot of things through this kind of experience. For assignment and programming projects, usually we give you, I think most likely the first maybe 1 or 2 days are very lenient, mild reduction on the overall score, then more severe score, penalties every day afterwards. Okay, if you got any question, just feel free to put up your hand and I can follow up. So for the exams, finally we have an exam, and the number one thing is that, especially for students actually unfamiliar with the system here, the final exam is we try to be fair to everybody. So basically, if you have taken this final exam, you can only take one of the exams, final exam or supplementary exam. Okay, so if you have taken the final exam, but for example, despite you feel very unwell in the morning, or in the past, there are students who actually had a traffic accident just before the exam on the way to the venue, and which really adversely affect him or her. But the thing that if you got these kind of things, you'd rather don't attend the exam, just file for special considerations. So you got another chance, which is a supplementary exam. Okay, if you have sit in the final exam, then there is no chance you can go into the supplementary exam. Okay, even if something really happens at the morning or during the exam, right? So the final marks will actually be like 15%. So basically, the assignment, project, and lab together occupies 45%, like slightly less than half, and the exam is 55%. But there is another condition that you must achieve more than 40 out of 100 in the final exam. So this is the double pass scheme. Okay, so I'd like to put the worst aspects of the course beforehand. So this course is designed to have broad coverage. Actually, to be honest, I mean, there are actually a lot of things happening in the field, and honestly speaking, I think, it really warrants 2 courses, but there are a lot of physical limitations and so on and so forth. So I try to squeeze, hand-pick some of the important stuff, trying to squeeze into this course. Unfortunately, it will be a little bit broad, and due to historical reasons, we still need to use maybe 2 weeks to cover the data warehousing part. So for the rest, we'll actually mainly focus on data mining or machine learning parts. So so the coverage is a little bit wild because you are going to switch from more like a data management and an analytical point of view to more like a predictive modeling and mathematics and the machine learning stuff. The workload is at least heavier than the average. So if you really want to master these kind of things well, and if you are really new to machine learning, and some of the, for example, in the data warehousing part, we also have something on the algorithm, especially recursive algorithm and dynamic programming. So if you are new to these kind of techniques, these topics alone is actually quite involved, and you probably need to set aside a good chunk of time to study it. But I think these are actually very important techniques, so I really want you guys to at least get some idea of what they can do and what's the basic idea. So just in case you ever need to use them, you can actually go back and grab some books or references and make your way there. We do have a large course class. Historically, due to a lot of reasons, there are actually quite a lot of students failing this course. Okay, despite a lot of due to all sorts of reasons. Again, I just give you facts. It's really, I mean, it's like we are not really doing any kind of very tricky job trying to trick you guys or whatever, but due to a lot of reasons, especially if you are also taking other courses with heavy workload, so time might be one issue, and maybe, and also this course requires you to, or I really want to push you guys to have a deeper understanding of the ideas behind all these kind of concepts and algorithms. So it takes some time for you to. You probably need to get the basic form of it, so basically what's it, and really think about why it is designed so. So for all these kind of reasons, we do have a high fail rates. Especially for those students who actually are on, I think, I don't know what it's called, but some students, I think they cannot fail more than, one more course. Otherwise, they will be expelled or enter into probation, whatever status. Or if you are not really, for example, you are not really good at, I would say, it's just like a rule of thumb, but it might not apply to you, but I think if you are not very comfortable with programming and math, probably it's going to be pretty hard for you. So I do want to warn all of you that you really need to commit a bit of time and energy into the course. Otherwise, there are statistically it's failing at least 20% of students every session. And also, in fact, plagiarism is, personally, don't quote me, but basically I think there are actually a lot of cases of plagiarism. Okay. So if I spot any, I'll just deal with it. I mean, so I really want to warn you. For example, one of the things is called collusion. So even if you guys can actually discuss all the assignments, project, whatever together, but you really need to do it by yourself, okay? Never ever pass your file to anybody else, otherwise it gets you into trouble as well. So we do have a very rigid policy on plagiarism. Again, this is set by university, and I think that should be the case. So again, if you are not familiar, I mean, in computer science, it's slightly different. We don't have essay or these kind of things. But again, writing code, attempting this kind of assignment, actually, you really need to do it on your own. Yeah, if there are anything affecting your study due to health reason, mental reason, or other unexpected situations, there are actually special considerations you can apply for. So again, I think the university is moving everything towards this kind of electronic, sort of like the standard procedure, SOP. For example, previously, if you want to waive some kind of prerequisites of this course, you can, I can, as a lecturer in charge, I can approve it, but now you actually need to go to the faculty website and fill in the form and go from there, okay? So again, special consideration is something that you can apply if there are anything. So in the past, there are all sorts of, I would say, reasons or explanations or whatever, especially after the final marks is revealed to the student. Unfortunately, I wouldn't accept any of these and any similar claims there. This is, again, for all the marks and all the assessment, we are absolutely trying to do it on a fair ground. So we, for example, we don't even, actually, for such a large class, we never have any personal bias towards anybody. But we try to be as objective as possible. So unfortunately, even if you spend a lot of time or efforts on this course, but still, let's say your final exam or your project really is below the passing mark, there is really nothing I can do, right? This, I mean, it's not because you actually spend a lot of time or you think you have a good understanding, but for some reason you didn't demonstrate it through all the assessment. Of course, I mean, if there are very, very special reasons, I mean, you can discuss with me, and there are always special consideration out there. But for most of the cases, yeah, these kind of things, yeah, there is nothing I can do. So back to the teaching materials. For the lecture notes, we actually let's talk about textbooks. So what we are going to do is that we actually will use the third one, but sort of not really that much. Actually, that book was published, I think, almost more than 10 years ago, and So many of the things are actually out of date. So this one is actually, I think the last version is in 2013 or something, I think. So it's already 5 years. So the first one is actually from Stanford. And if you go to their web, the URL probably is not this one, but you just search for the name, mining of massive data sets. I think they are actually, the authors are trying to write the third version. Some of the chapters are already on there, but again, there are not too much change. So really speaking, the first one is more up to date. And the second book is a good one. It's almost like a monograph on the special topic of data warehouse. And if you use any of the computers in UNSW, or I think just by connecting EDU, UNSW Wi-Fi, you should be able to download it as a PDF. Okay, and for the first book, it's actually freely, all the slides, whatever, actually are freely available. So of course, we are going to do some modification there. So in terms of textbooks, you should have them on your laptop or digital devices. As I said, I mean, even for the Stanford ones, if you look at the contents, they cover some of the basic stuffs, because if you write a textbook, it takes years to write up and do the editing and publish somewhere online or even through some traditional publisher. And you are not going to talk about some of the latest stuffs. So one of the things I'm trying to do in this course is that to give you some idea of the, I mean, we first of all focus on the most basic and the important stuffs. And if I have time, I will actually emphasize more on the latest development in research. So to prepare you guys for some kind of, to give you some kind of heads up on where the technology are trending or heading towards. So we also have some kind of reference books for, if you don't have the Java Professor Hans book, this book from Minnesota, University of Minnesota is also a pretty good one, mainly on the data mining parts. And actually this written one is too old, and we're now using Java. So the last one is actually pretty new, and the author is actually doing a pretty good job in explaining a lot of things. So that's also a good reference book as well. So for software, we are going to mainly use Python. And if you don't want the hassles, the best way to download Anaconda. Of course, I mean, Anaconda takes quite a huge amount of space. It's not really huge, I think several gigabytes. So there are actually mini Conda, but again, you need to know how to install package by yourself. But anyway, for those of you who, and it runs both under, I think, under all the operating system, major operating systems. So, and we are using Python 3. Again, Python 2 and Python 3 have slightly different syntax, and many of the programs are not compatible. Yeah, we really should not write any code in Python 2. It's really hindering the evolution of the whole language, right? And we are going to use the Jupyter Notebook. Again, actually, I think just last month or whatever, there is a new version, like the next generation of the Jupyter Notebooks called, I think called whatever lab, Jupyter Lab or something like that. So I think it's still alpha version, but it's actually close to release. I think they are expected to release this year. Yeah, so it should be okay. It's backward compatible, so depending on which one you want to use. But yeah, I'm just too old to switch to new stuff, so I just stay with Jupyter Notebook for now. And we're going to use Python libraries. And again, these are the libraries that if you are doing traditional machine learning or data mining, these are really, you probably need some time to study them, but overall, it's actually designed pretty well, the APIs, and of course, there are some kind of new concepts there. But once you spend some time, I mean, it's actually really worthwhile to spend some time studying NumPy pandas, maybe the plotting libraries. Plotting is easy, mainly the NumPy and the pandas, so that you really will appreciate how easy it is to manipulate your data and actually do it efficiently. So when we go to the machine learning parts, we are going to mainly use scikit-learn. So basically, you need to know how to install libraries, and we do have sort of like the introductory notebook for Python and pandas. But again, there are huge numbers of tutorials or similar notebooks out there, and also the documentation is, overall speaking, is pretty good. And we are not going to use very advanced stuff. For example, in NumPy, and also in pandas, you can actually do very sophisticated operations. But we are probably just going to do very basic ones. Of course, if you are interested, you can learn more advanced features. So many of the materials will actually be taken from research papers or other textbooks. Not only all the kind of reference books or textbooks, and I'll put them into the lecture slides. Okay, so if I mention anything, I'll put it on the web page. Okay, so this is a preliminary schedule of the course. We are going to do the course overview and some kind of introduction today. And next 2 weeks, 1 or 2 weeks, again, I'm really trying to squeeze more time. So let me see if I can finish data warehousing in 1 week, but probably need a little bit more. Then we move on really into the, if you like, data mining and the machine learning part. So we are going to do some kind of review on mathematics, mainly the linear algebra. So we are trying to give you it's called algebraic bracket view of the linear algebra. So rather than thinking about linear algebra as some kind of computation, as you can write a for loop to do that, really trying to understand what it means by a vector and what it means by a matrix. So these will actually be really, really useful if you really want to go deep into machine learning, because many of the symbols are, things are not only written in matrix format or vectorized, but also they convey important messages. So I try to build these kind of connections. And then we talk about data preprocessing. Then we spend most of the time on classifications, talking about different types of classification models. And the next major part is clustering. It's also called the unsupervised learning part. And finally, we talk about associative mining. So again, we are still finalizing the project. So we probably will stick some advanced topic, maybe something related to adversarial machine learning somewhere. Probably not in the last week, but somewhere in between. But again, that's how we try to arrange all the content. Okay, let me quickly talk about the objectives and the requirements. So as I said, we are not able to cover so many stuffs. But what we are trying to do is that we really focus on the practically useful data mining and machine learning techniques and the concepts. So, we also try to foster deeper understanding of the important parts. Okay. To put it simply, I don't really want you guys to remember the equations or just memorize the algorithms as they are. Really understand them and trying to figure out why they are doing something like this. And you probably can piece, it's like a puzzle game. It probably takes you a while looks like slower than directly recalling the algorithm or the concept from memory, but you do have your own, I do want you to have your own understanding. And then you will actually see that if you ever want to move deeper into machine learning or even more advanced parts, I do believe that these kind of things actually will carry you a long way to really understand what's going on for these kind of advanced models. It's not just mathematics there, it's really they use this piece of tools or use this kind of concepts trying to solve some kind of problem. You really need to understand why we need to have these kind of things. And also, for many of the models, for example, let's say logistic regression or SVM or these kind of traditional, very classical models, there are actually at least more than one way to interpret them, and each of the interpretation looks like redundant. Why do I need to know more than one way to look at the model? But basically, if you try to solve a particular problem, you actually will see that one view is actually especially handy. For example, let's we talk about linear regression. You can, if you take the latent variable model, you can actually think about, okay, my observed data actually is affected by a certain kind of noise. So the model itself, all the formula you learned actually assume that the noise is mean. So basically have the same variance and the mean is 0 and it's Gaussian noise. But there are actually a lot of scenarios where you will see that your noise is actually probably biased or probably it's a Laplacian noise or some other kind of noise or even non-parametric ways. But basically you can do some kind of sampling trying to get an approximate distribution density estimation of the noise. Then you can modify your model, okay? So these are actually the things you really, I think this kind of university education will give you rather than, for example, later when you really go to the programming, you will see that you almost do not really need to know anything about the machine learning theory or models or algorithms, except knowing how to call the right function from the library. And by design, the scikit-learn library is actually very easy to call. You don't even, I think many of the quite sizable percentage of the learners will actually treat everything as a black box. This is really, really bad for traditional models where we do have a lot of deep understanding of it. For example, even for deep learnings, currently it's a black box, but the way our science and the engineering going is that really try to open up the box and really understand what's going on. Nobody really want to rely some critical decision on some black box method, right? Yeah. Okay, that's a good question. So we haven't come to that part, but just one short answer is that regression and classification are the same. From one point, they are actually attacking the same problem. So all the, I cannot say all, but most of the classification method actually can be interpreted as doing some kind of regression in some space, maybe probabilistic space or whatever. So basically, they are actually the same thing. For example, if you ever heard about XGBoost, that's like very useful tool. Basically, the internal is actually a regression tree, but it usually is used as a classification model. So, yeah, we'll come to this part when we talk about the classification models. Okay, and the third thing is that many of the times, if you really get your hands dirty and really play with the data, for example, if you really understand regression or really understand SVM or whatever, you can, especially with the plotting libraries, I strongly suggest that you actually can think about a very simple case in 1D or 2D, or even in 3D. Basically, you can plot a lot of things, and you can test your understanding. Try to, before you actually see the results, think about what do you expect. No matter the outcome is the same or different from what your expectation, you actually learn something. In fact, if it's different, you learn more. Okay, so don't be afraid of failing or whatever. I think one of my favorite quotes is that if you are not failing from time to time, it means you are not trying anything innovative, right? You just try to solve mundane problems. So it's very safe, but you are not learning anything or doing anything great. Yeah. So unfortunately, I mean, I think you really want to. I think the material, the knowledge itself requires that you need to have some good background in mathematics. It doesn't mean that you actually, of course, I mean, I do expect all of you actually learn the linear algebra, calculus, probability, and statistics, and in some stage in your life. Probably many of them are actually not used, and you forgot about it. It's all okay. We are not really a mathematics course, but and we are going to do some kind of review on linear algebra, which is anyway. I mean, most of the cases, especially for if you took it many years back, probably it's not done in from this kind of algebra point of view, so it doesn't matter. But generally speaking, you need to be able to do certain kind of mathematics. You need to understand the symbols rather than just, if your style is always memorize the equations and have absolutely no idea, then or desire to understand why it's something like this, then probably, or you don't really want to learn these kind of new stuffs, probably it's going to be hard. And also, unfortunately, you are going to use quite a bunch of new libraries if you never use these kind of libraries. If you don't even know how to do proper debugging or how to solve all the kind of stupid issues, especially, I mean, you have different operating system, you might have strange dependency, you might have installed something which breaks the dependency or all these kind of things. As a rule of thumb, I mean, you really need to expect that you are not the first person and definitely not the last person to have these kind of questions. So I strongly suggest that you grab the error message, especially these kind of common things, and just search Google, right? If you don't do this very often, then probably it's going to be hard for you. As I said, I mean, don't just memorize concepts, equations, and algorithms. You have to sort of like know the forms and know what they are talking about, what kind of problem they are talking about, and what each symbol means in the equation, right? But really ask why, ask what's the meaning. There must be some kind of simple explanation out there, okay? For most of the things we are talking about, we're not really doing rocket science. And try to, if you search, I think there is a famous learning method called the Feynman's method, okay, by the physicist Feynman. So basically, he is like he actually his studying method is that you actually understand these kind of things and try to describe it in very simple words. Don't try not to use jargon. Try to use everyday analogies or whatever. Try to explain it to someone else and get their feedbacks. So if you are able to do this and try to convince other people, okay, and to get the other audience to understand what's going on, that actually means you actually learn a lot. Okay, the ability to describe it in your own language is really, really important. Even in research, where actually this is actually a fundamental skill you need to master. And of course, I mean, we are continuously trying to revamp the course because the whole field is actually moving so fast. I'm trying very best within what I can, trying to bring this more contents and all the viewpoints more up to date. And of course, I mean, if you got any feedback, suggestions, or criticism, just let me know anonymously or through the forum or email or whatever ways. Okay. Okay, so let's have 10 minutes break, and then we finish the rest of the stuffs.
So how exactly is this supposed to differ from actual chicken? Because I'm actually going to both of them, so I'm like, okay.
I need to turn this off. Just a minute.
quick question. Is there much overlap between this course and
9417.
big data management?
Oh.
Because I found that book, big data management, sort of brought a lot of content.
Yeah, so again, I haven't talked to Shi, so I don't know his plan for this semester.
Oh, because I'm talking about last time. Because last sem, basically a lot of the stuff that he covered was in that course.
Yeah, but I think he really covered, he doesn't really cover, I think he just covered SDL.
Oh yeah, but like basically things about similarity, how to calculate similarity, but it was all done in Hadoop.
Yeah, the focus is, we try to minimize overlap. So I think if you look at that book, it actually has many chapters. I think the only thing, last time he actually mentioned, I think he mentioned something about SDL. So this time,
Yeah, okay. So that's cool. And what's the like rate of high distinctions for this course? Like when you essentially class the high distinctions?
That's a good question. I can definitely look up this.
That'd be great, yeah. Because I mean, I'm looking to get like a good mark this sem, so I can do the thesis next sem.
From my memory, it's still not too mainly, the problem is the lower end of because the large population, the memory is too large. So basically, the upper part is pretty, I think the upper part is pretty low.
Okay, right. So if you exclude the failures, it's normally distributed. So you'd expect that like about 30% is like one standard deviation away from the mean. You know what I mean? Like, is it like essentially 30% is.
It is statistical for the last time, that's
Yeah. Last time, yeah. Oh, okay. Thank you.
Okay. Okay, let's resume. Okay, so let's look at one very simple example. My goal is that trying to, so later when we talk about probabilistic classifiers, or especially Bayes-based classifiers, I think things will be much more clear. But the general thing is that we really need to, sometimes if we formulate the problem into this kind of mathematical terms, it actually helps us to really understand what's going on and sometimes avoid us making wrong decisions. Okay, so basically think about a person who actually do some kind of test. Think about any, so basically he somehow knows that the probability that patients with some kind of disease, suppose, you do this kind of test, trying to do some kind of screening on some kind of disease, right? So let's call it beta, and the test name is alpha. So basically, the fact he knows is that to some extent it's fairly easy to gather from even from online sources. You can actually know the percentage. So the probability that the patient with this deadly disease, beta disease, having a positive alpha test is 99%. Okay, so let's say this is arbitrary high number, so it's a fairly large number. So should John be too worried about any bad outcome, right? Having this deadly disease? Yeah.
I think given the information you get to say, because you've said, basically you're saying the false negative rate of the test is only 1%.
Yeah.
But that doesn't tell us anything about the false positive rate. Also, we need to know how common the disease is in the population in order to calculate the probability that he has the disease.
Yeah, I think, yeah. Well, so there are a few jargons there, but basically I think it's the same as what I try to illustrate. But I think, yeah, so if you are trained in this area, you probably will pick up that, okay, given this kind of information, first of all, there are not enough information. I cannot say or put a number on how what's the probability that John will actually do have this kind of disease. But I think for many of the untrained people, basically this looks like really a bad result. So essentially, if we want to model it, we are trying to. I need to change. Yeah. So if you want to model it, essentially the best way is that we try to say to model it as a conditional probability. Okay. So by the way, probability theory is, I would say one of, but arguably widely used scientific method trying to reason about uncertainty. There are other methods to do that, but arguably probability theory is actually one of the most popular one, and it's actually a very solid mathematical theory behind it. So basically, what we try to do is that given the fact that, so this bar says, okay, this is the given information, given that this patient actually have this positive result. So I use alpha to say, okay, the test result is positive. I can use put a bar there or put a not before it to say, okay, this is the result is negative. And we try to reason about what's the probability that the patient actually have this disease beta. Okay, so one of the rules we are going to use is the Bayes rules. So Bayes theorem. So basically, it says you can swap these two things. So what you do is that you can see that now this is beta condition on alpha. I can reverse the two things. Say, okay, I want to try to rewrite the equation into something like I switched the two parts. In order to do that, you actually need to have these two parts as well. Okay, and to some extent, this part is already known. This is actually given in the fact. So this actually means if you really do have this disease, basically this test is very accurate, right? So basically only 1% of people having this disease will not be detected. 99% of people actually will. So this is 0.99. Okay, but the problem that you do have two other quantities, P beta over P alpha, which is unknown. So basically you cannot fully determine the probability. So so this is a short answer, but if in machine learning, this is actually we won't go deep into the Bayes network or graphic models. Actually, I'll later mention some courses where they actually mainly focus on graphic models. But basically, this denominator basically is notoriously hard to calculate. Okay, but in our case, it's easy. So let's think about it. So this P alpha essentially is actually sum of, okay, because we only have two outcomes, so basically it's alpha beta plus P alpha not beta. So if I put a bar on top of beta, it means not beta, right? Because beta is a binary variable, either you have the disease or not. So for each of them, you can actually expand it using this kind of things. So, so in other words, you can actually find that this part and this part is the same. Now the only thing is actually this part. Okay, this part is actually what one of the students just answered. So if you look at the first part, it's first of all you need to know. By the way, this P beta, you can argue that this is actually in the general population. What's the percentage of people? I mean, it's like an empirical estimate. If you just look up the disease online in most of the resources, I mean, definitely it will be pretty easy to find this P beta. It means, let's say, this kind of disease is, let's say, 1 in 1 million, or let's say 13 in 1 million, or whatever. So basically, you can get some idea of the P beta. And the P not beta is easy, right? Because beta is a binary, so it's 1 minus P beta. So the only thing which is uncertain is actually this one. So this actually means for people who do not have this disease, what's the probability that this alpha test result will also be true? Okay, so this is actually the false positive. I think the student actually just mentioned. So yeah, so to this step, you can see that okay, you can get your hands on all different things, but all the key parameters you want to figure out is actually this probability alpha given not beta. And in fact, I do encourage, I mean, in Python notebook, you can actually do plotting very easily. So if you really plot the function, so you can actually see that, again, yeah, so you cannot see the x-axis. I think it should be alpha given not beta. So this is actually this axis is the value that we are not given, but basically it's in percentage. So 10 means 10%. So 10 means false positive is 10%. So if the false positive is even 2%, you can actually do this kind of things. You can actually see. So basically, I think this is something like 1, 2, 3, 4, 40%. So so if that parameter, which is the false positive rate, is actually 2%, basically the probability that your test result, alpha test result, is true, and you have the disease is actually 40%. Okay, so it's sort of like much smaller than otherwise many of the people would think, right? And based on this figure, you can actually see that if the false positive rate is actually even smaller, then basically the probability will actually increase very fast. But if it's going to be log. By the way, this is actually log plot. So this is really a key parameter. Okay. So for those who are further interested, there is actually a related thing called prosecutor's fallacy. So in some kind of legal systems, these are actually real examples where suppose some of the prosecutors actually use this kind of flawed reasoning trying to convict some suspects of, let's say, murdering or whatever. And I think there are actually several cases where the innocent people was actually convicted and sent to prison, and later actually people actually figured out and they just reverted the whole thing. But again, this actually is causing real problem in people's life. It's actually a very simple there are actually multiple reasons contributing to that, but one of the things is actually to miss. So basically, if you think about people actually mess up with these two numbers. So this number is 99%. This is very high. This number high does not really mean this number is high. Okay, but so I think the case is that in UK, so basically a woman actually had a baby, and the baby died within first 6 weeks. And then after some time, she had another baby and died in 6 weeks again. So the prosecutor actually got some expert in, let's say, early, child disease, whatever. So the expert says, okay, this kind of things, in UK, it actually happens with very small probability. But if these two things occurs twice in a row, it's even rare. So I think at that time it was people wrongly believed that okay, since this property is so rare, the woman must have killed her baby. So basically, I think the woman was in prison for 6 years and before released. But it's really a tragic story. I think the woman actually developed some, I think maybe depression, whatever, during the right. You can imagine how it's already pretty bad to lose your kids. Newborns, and then you are actually defamed and put into jail. So I think that's really a tragic story. Okay, so let me quickly go through the slides. I do believe that most of you actually should have access to some kind of computer, either the laptop or PCs or whatever. Of course, you can use I think for postgrads, there are postgraduate labs, and there are plenty of labs around the CSC building. So basically, you can use it. But one thing I really happened quite a lot in the past is that unfortunately our server and all the marking system is actually going to run under Linux in our system. So do make sure your program actually works under Linux environment, so you can do the debugging or development, let's say on your Windows or Mac or whatever. Mac is probably easier to deal with because it's very similar to Linux. But one of the notorious things is that, for example, the directory separator in Windows and Linux are different. One is backslash, the other is forward slash. So basically, if you happen to put your data somewhere, and if you put in the wrong thing, your code might not work under Linux. And also, there are other subtle differences. Let's say for the text file, for Mac, Windows, and Linux, the line. So basically, I think one uses LF, the other one uses CR, and the other one uses both. So it's again, if you use some kind of portable, libraries, they can handle these kind of things. Should not be a problem. For example, I think in Python, but I think if you do it in, I think for most of my code, actually I do it in my Mac, and it runs correctly on Linux as well. But again, you'd better double check. And another kind of common problem is that for our assignment and maybe for the project, you need to upload your submissions using the GIF system. So it's a system built by the school. First of all, I think they also have a web interface, but I think there are feedback saying that if you really upload a large one, it really depends on how large it is. Sometimes it fails, but the more traditional way is that you actually upload the file into your CAC account and then open up a console window. You can do this typically at home using SSH client, and you can actually submit it to the system. So there are a few things. Do watch out for the file size and the dates. Don't submit the wrong file. It's not uncommon that students just submitted the project or assignment specification because it's also in PDF format. So you see the assignment specification submitted as the answer. And also sometimes, I mean, especially if you are doing this at your home, and there might be some kind of network errors that you didn't notice. So do check you have, because once you submit it using the command line, you can actually, I think there's another command to check the file size and the dates, whatever. And also, I think the command line version will ask you, I forgot what's the wording, but basically I think you need to answer yes to say, okay, you do it by yourself and so on and so forth. So if you forgot to do this, I think it will exist the give command line, but your submission was not made, okay? So because you didn't say yes. So if you really submit it, I think the last line will be maybe something like submitted successfully or on a particular date or whatever. So just watch for the successful message to make sure you really submit your assignment. Oh, another thing is actually the file name. So in Linux and I think in Mac, capital letter and small letter actually are different for the file names or whatever. But in Windows, I think it's the same. So that's another common problem. We also have a bunch of other special calls. Again, I didn't double check the latest because I think there are some change in the different kind of streams. But I think there are related calls. There are 9319. I think typically taught by Raymond. Again, I don't know what's the latest. Maybe I think all the lectures are continuously updating their contents. Usually it's on compression and text and maybe XML databases. So actually, I think I think one of the things they are going to cover in the course is actually personally I think it's a very ingenious finding because if you ever think about a compression, right? It means you have a large file and you want to save space, so you compress it. But everybody knows that once it's compressed, it's smaller on the disk, but whenever you use it, even if you load it and do some kind of things, you probably need to decompress them all, or at least decompress part of them. So basically, you are going to spend more time, right, accessing the file. On the other hand, if you build some kind of index, for example, if I have some text file, if it's a really large bunch of text file, you really need to build some kind of index. If you ever heard about lec1 or what's it called? There is basically distributed indexing based on lec1. Basically, you actually build additional data structures such that you spend more space, but the query processing time will be faster. So what I think we'll be talking, I think the course will actually be talking about is a technique which actually not only compress the file, but also build some kind of index inside. So basically, the file size actually becomes smaller, yet it still supports a very efficient kind of search. Okay, so if you think about it, this is almost like unbelievable, right? you usually sacrifice space for time or the other way around. But using some kind of clever algorithm, you can actually do both. So there are another course which is 9313. I think it will. I think one of the students actually told me that they are going to use one of the I think the Stanford textbook. But as far as I understand, they actually focus more on the big data system part. I don't know if Xin will actually introduce some other stuffs, but yeah, that will actually the focus will mainly be on Hadoop and Spark and all these kind of things. So I'm also teaching another course the next semester. It's called the Information Retrieval and the Search Engine. But due to my research, so it's I'm going blending the natural language processing there, and sort of like most likely we are going to next time we are going to put in a few. Last time we actually talked about the embedding part, which is a very simple kind of deep learning models. If I have time, this time we probably will put in a little bit more deep learning architectures for NLP, because that's really the standard, widely adopted solutions nowadays. So if you are interested in machine learning, I think there are other courses. One of those courses which are very similar to this one. So for this course, I think maybe 60% or 70% will actually, unfortunately, or fortunately, it will actually be related to machine learning. And I think 9417 will be entirely on machine learning and data mining. Especially for students who actually, again, I think if you don't have too much time or just want to take one of them, I think either one will do. So another course is Alan's course on neural network and deep learning. So it's a revamped course, so focusing more on deep learning parts. Let me quickly explain. I think knowing the traditional machine learning models, like in this course or 9417, and actually in Edwin's course, is actually helpful because to some extent, this kind of deep learning or neural networks are sort of like have a very low barrier for everybody. Okay, so basically, currently we still know very little about them, and but many of the more advanced versions or some kind of intuitions are still based on. You can still find traces of many traditional thinking still helpful in this area. So if you are just into solving some real problems and just use it as a tool without really considering deep into the machine learning or AI parts, I think deep learning is okay. But if you really have some background in traditional models, for one thing, you can actually better understand why deep learning actually works better in many cases than the traditional models. And also, when deep learning itself then is not sufficient, you can actually think about other ways to integrate traditional ideas rather than a typical model into the deep learning part. So I think these two courses are relatively easy, and if you want to challenge yourself or are interested in the specifically graphic models, I think 9418 by Edwin is actually a pretty good one. The only thing that I don't know when he is going to teach it again, but it's going to be pretty hard, but it's going to cover, I think, graphic models and Gaussian processes, because Edwin is doing mainly Gaussian processes. Okay? If you are interested in doing some kind of research, so I'm always looking for good PhD or master. So the only problem that UNSW actually changed the scheme. So previously you have master by research. I believe now they don't have this one. But anyway, if you are interested in this kind of opportunities, or one special thing is actually the research project. I think if you are in the MIT stream, you can actually take on 12 unit credit or 18 unit credit course. But basically, I normally do not open up this kind of projects because it's really, one semester is really too short. If you are really interested to do that, I mean, try to do well in this course and really contact me by the end of this semester so that we actually can have a chat and fix a preliminary topic, and you really need to start reading papers. If you just start from the, let's say, week 1 or week 0 and determine the topics and start reading papers and really understand them, there's no way you can do anything innovative. So, yeah, so if you ever think about this, it's like this. The other thing that we do have a course project, but for those of you who actually want to do your own research project, or I mean, own project, you can actually come up to me and we can actually talk before week 4. So if it's okay, you can actually do your own projects. Actually, later I'll show you one of the students' project. Basically, he and his friends actually set up a company, and he want to apply what we learned to his own business, right? It's well-motivated problem. So, and it turns out that he's doing pretty well. So, yeah. Okay, so so let me reiterate a few things. I really want to set out that, okay, or at least try to put this question into your mind. So from my point of view, actually I see this kind of evident trend. I think most of you should feel it. Nowadays, actually, we are at this kind of turning point where some people are even talking about AI might replace human being, right? Cause disasters and so on and so forth. Basically, there are actually a lot of development in this, especially AI, but also hardware-wise. I mean, there are a lot of new things, and if you look at the breakthroughs, they are actually coming faster and faster. Okay, traditional wisdom might be that you actually learn enough stuff in your university, or even as a master or as a PhD, and then you can actually solve a lot of problems. And you probably should have enough knowledge, right? But I think that time has passed, and if you don't keep on learning or improving yourself, I mean, I think if you are talking about competitive places, positions, or area, I think you will actually easily be out of date, right? So that's what I really want you to learn in this course, in the sense that everything we talk about is actually very basic, because we have to cover the basic stuffs. But think about, let's say, data structure and algorithm, right? We talk about trees and graphs and so on and so forth. But these are really, really basic things. And even if you think about, for example, AlphaGo, right? They actually use the Monte Carlo tree search algorithm. So basically, it's a search tree. It's a search space exploration. So they are, of course, different from the standard trees or standard search problems. But again, if you really understand the essence and can understand what's new in this area, you probably will be much easier to pick up new things and actually do well in these kind of areas. Okay, so that's really I really want you to think about. It's not really the mark or just memorizing everything or just grab some kind of scores. To some extent, I mean, nowadays, I mean, I think people are more and more realizing that, okay, for example, if you really go to highly competitive places, even if you get very high score, if you don't really have a good understanding or the ability to solve new problems, honestly speaking, I don't think you can go through several rounds of interviews for these kind of big companies, right? So for me, actually, I have PhD students and I have some other students who actually go through these kind of interviews, and some of them actually landed in these top tech companies. So basically, I think they all have the ability that trying to really understand something and be able to adapt to new cases. These are the abilities that I think really buy you a lot of advantage in the long run. Okay, so as I said, I mean the workload is actually pretty high, so I do recommend you guys to plan ahead for the course. The second thing that I want you to push you outside your comfortable zone. Okay, so even if you think you understand this, okay, sometimes, I mean, even my experience, you explain to someone else, you actually found, okay, there is a logical flaw, or maybe the other guys, why don't you just do this, right? So we'll try to cover many of these kind of things, maybe in the lecture or in the forum or in assignments or in other ways. But again, it's always good so that you can ask these kind of questions and you can actually try to answer them by yourself. And try to, I think that you probably want to review some kind of, especially the new stuffs, sort of like within the same week while you still have memory. Oh, by the way, all the lecture videos will actually be posted online. I still need to set up the Moodle system and to put so that you guys can access the URL. But basically, yeah, you guys should have access to the video by next week. I mean, I'll settle this this week. So, and also, I think in many cases, you really need to do it by yourself. Okay, especially there are quite a large percentage of students who actually learn much better by seeing and doing. I mean, just seeing and hearing about things does not really, or even thinking a lot. But if you really do it and print out something or say, okay, what if, right? What if this kind of question? You can easily change all these kind of things. And you will actually see what's going on. And this might give you even new understandings or new questions. These are actually going to be very helpful. For example, if you ever heard about a Kaggle competition or these kind of things, again, I'm not saying competition is the best thing to demonstrate your understanding or your abilities, but if you think about, I mean, one of the critical things is really to understand the problem and understand the model and do some kind of, for example, especially for the traditional one, or even for the deep learning-based model, sometimes if you do some kind of feature engineering, or you partition the problem into different smaller problems and solve them using different models, they actually can give you much better results. Okay, but again, these are actually built upon a good understanding of the problem domain and understanding of how your model performs and what kind of things I might be able to do. There is no set rule. I mean, there are a bunch of things you can do. You can do normalization. You can do different kind of standardizations, but you probably don't know why. Okay, but if you understand what's going on, I mean, sometimes standardization actually not only, make everything within the same range, but also make the gradient sort of like unequal magnitude, so that the optimization is much easier to do, right? Again, these are actually the things that you probably cannot find in any of the textbooks, but if you really look at the problem and think about it, and this will be your understanding, and this will help you in a long way. So this is, I just, the sources cannot be seen, but basically I borrow some, I think, pretty good sort of like motivational pictures from someone's blog. Okay, so that's all for the quick introduction. So any questions? Okay, if not, I think let's have 10 minutes break. Then we quickly go through the introduction. I won't go through, oh, by the way, one thing that sometimes when I get very excited, I speak very fast. And so I'll try to calm myself down. But don't worry. I mean, even my PhD student cannot follow me, so it's very common. So if you got anything unclear, whatever, feel free to interrupt me. And the other thing is that, so basically, I don't usually follow exactly the slides. I'll actually derive my own stuffs because I think everybody can read the slides, and if there are any questions, we can discuss. But I will actually handpick a few important things I want to illustrate. So that's just my style, and you can, you probably will get used to it over the next few weeks. Okay, so let's have 10 minutes break, and then we'll do a very quick introduction, but I mainly want to go through 2 additional slides, which I'll upload later. One is a student's project, and the other is like a telecom training analysis.
就是说，如果你前面做的不知道的话，我会递一些答案，然后你可以一下那个对我说，只要在我突然间比如说讲这我其实不做图像，就是你要对图像感兴趣的话，我可能就在一起。你们要找到一个切合点，大家都感兴趣。第二个就是说，我要去判断你们个人怎么样，有些方面怎么样。出来的话是说，本质上是说没人算，但是呢，我们可能会有些想法啊，或者说想，或者说觉得有机会啊，或者这两个放在一起，我也肯定会期待，会需要一些更多的靠谱的。如果能够提早这个的话，就是如果我建议我这个差不多再过去。如果我们大家第三题。 非常如果做这种情况可能需要长时间做一些别的加速可以在一点。这玩意儿就是说，还要利用硬件加速实现一些技术加速比较快。
Okay, let's resume. In the rest of time, I'll quickly go through some of the major things. Usually, introduction is really boring. I mean, even to me. But I think what I'm trying to do is we'll focus on some of the contents we are going to talk about, especially for those who actually are new to machine learning or statistics or these kind of things. There are plenty of applications. Again, slide is based on Professor Han's book. It's kind of really out of dated. But nowadays, we actually are dealing with a bunch of very new applications. For one thing, for example, self-driving cars, right? And this kind of AlphaGo, this kind of playing human-level games, even winning the champions. And also, there are, especially for deep learning, actually making a lot of progress into images and texts. So, for example, currently I'm collaborating with a professor from medical school, and so we are trying to really put this kind of idea into doctor's mind. Unfortunately, if you really know the details, those professors are oncologists and so on and so forth, so they are dealing with deadly diseases. So to be honest, currently we know very little about many of the diseases, so better not to have any diseases. But basically, there are some kind of domain knowledge they can do. They have some kind of pointing system trying to, for example, one of the things is to really to predict the prognosis. So meaning that, for example, what will, let's say whether you will survive or what's the survive probability after maybe 5 years or 3 years of the operation or discovery of the diseases. And for one thing, I mean, some of the, for example, from the government point of view, it's actually also very meaningful in the sense that if you can do better prediction, basically you can actually put more money effectively on people who actually really need them. And if you know, actually, I'm not an expert in medical, but simply because of the collaborating with them and have to know a little bit dire effects. For example, in Australia, actually, I think diabetes 2 is actually one of the causing a lot of problems. I mean, from a national point of view, it actually causes a lot of health bill things. So people actually nowadays actually there are a lot of so there is a holistic treatment. For example, starting from education, right? Health diet, proper this kind of exercise and so on and so forth. But we need to know what are the risk factors, right? And also whenever you have the early signs and they need to detect whether this will end up with very severe, other kind of things or not. And so currently, actually, a lot of things actually are not done in using massive data. So many of them are actually still based on some kind of hype. So the predominant thinking is that, okay, you come up with some hypothesis, right? Just if you imagine, if you heard about, okay, people are actually trying different kind of genes on your certain chromosomes and they're trying to say, okay, maybe this gene is related to a particular disease. And they come up with a lot of expensive and lengthy experiment. And if you are lucky, you actually prove some kind of association, and then this is actually good. For example, in machine learning, one of the things typically criticized is that we actually are only finding correlations or finding predictive attributes. We are not really doing so-called causality. Okay, but if you really talk about understanding how the disease evolves and how to, once you really understand the whole mechanism, you can actually find better drugs or treatment to cure the disease. So, of course, I mean, in machine learning, there are small branch people doing causal machine learning, but again, this is actually not the dominant field. But I just mentioned this because personally, I think this is also very important. But causality is very hard to approach. Okay, so in short, I think we are actually seeing the same phenomenon. So nowadays, we actually can accumulate more and more data. Okay, and if you think about Web 2.0, it's all about UGC, user-generated contents, right? And nowadays, actually, I think everybody is actually using mobile, and mobile actually itself provide even richer functionalities. If you ever heard about, I don't know if it's fixed now, but previously, I think there are reports that, okay, Apple are collecting your trajectory and all these kind of things and secretly uploading to their server or whatever. So basically, if you, for example, if you heard about the Australian bank, right? I mean, all these banks, they are actually laying off staffs, and this is going to be a global trend because for one thing, not many people, I think, are willing to go to the bank branches, right? Nowadays, you can purchase everything using either online transactions or a mobile phone or other kind of means. Similar things happen in many other countries, right? So this is a global trend. So basically, there are more and more data actually are computerized or electricalized, and no matter for government or for enterprises or even for yourself, if you can actually analyze these kind of data, there are actually a lot of patterns and there are a lot of hidden knowledge. And if we can grab them, you can actually do amazing things. Okay, what we are going to talk about in this course mainly cover two parts. But I'll spend most of the time on the data mining parts, but I just want to quickly mention that in the enterprise scenario, people actually are faced with the fact that nowadays it's very easy for you to create a database. Okay, for any of you actually who set up a blog using a database backend, MySQL typically, or some kind of wiki system. Let's say, I think Wikipedia also use Postgres or whatever, this kind of database system. There are actually plenty of open source or free database options there, not to mention Microsoft Access, right? It's claimed to be a database as well. So the problem is that everybody can actually easily create a database, and but the problem is that this also means that data actually is scattered around, and that there is no uniform way to encode the data and so on and so forth. Just like your file system, for example, even for me, I read research papers. To me, I mean, research paper or some data, experiment results, I mean, raw output, whatever, these are actually my precious data, right? But I mean, still I'm yet to find an effective way to organize my data. So I can remember, okay, I download this paper, or there must be some author who actually used this method in some paper, but I can only vaguely remember a few clues, and sometimes I mean it's erroneous, but basically there is no good way for me to find the information, or even automatically go through all this information, and you can present me with some kind of, maybe you can suggest me, okay, if you read this paper, other papers actually improve this paper, so you should also read it, right? So it will actually, even for researchers, it will be very useful. So the first part we are going to talk about is data warehousing and OLAP. So this stems from the business need that before you can do any kind of pattern mining or predictive modeling or unsupervised learning like clustering, segmentation, and these kind of things, the first thing you need to do is to really have a uniform repository of data and reconcile all the problems which are very frequently happening in the data. Okay, later I'll show my student's project. So because he is running his own business, and you can see, yeah, I probably forgot most of the anecdotal stories he told me, but yeah, you can actually see some of the figures where obviously the data is wrong. Okay, and if you do some kind of predictive modeling on this kind of incorrect data, definitely you might run the danger of enlarging the errors many times, right? And finally, once in the traditional way, I mean, before you do this kind of prediction is more like looking into the future, right? What kind of things you would expect, or let's say even for the medical case I mentioned, it hasn't happened yet. You want to do the prediction, so you can think about this kind of online analytical processing is more like a reporting. So just to summarize what has happened, okay. And they actually provide something called a what-if analysis. You can say, okay, what if my sales in this region actually increase by 10%? What's the final revenue I will get? Because it might have some kind of tax implication or other kind of things. So you can roughly thinking that, okay, the first part is really to summarize what happened, but also provide a good foundation to clean up all the data. And the second part is really to select part of data that you want to model and do some kind of specific modeling. I'll skip these kind of things, and the main task we are going to talk about is yeah. So we are going to talk about so we do have these two parts, which I call data pre-processing. Yeah, this is already after the data warehousing part. So first of all, we have the data warehousing part and the OLAP part, and we talk about some of the techniques there. And then we move on to the data pre-processing part, which includes cleaning, matching. Yeah, we won't talk too much about matching, and reduction and the transformation. So we might revisit some of the topics later. So even they are actually quite useful for the subsequent data mining or machine learning models. Then we actually can choose some kind of data mining algorithms. The algorithms we are going to talk about This is so we don't have this one. So we do have association rule mining. We actually put it late in the course. But basically, if you think about Amazon, and Netflix, you can think about these kind of things. Of course, Netflix, their original own algorithm is not disclosed, but they actually run some kind of competition and they're doing some kind of recommendation stuffs. But for Amazon, one of the first model or method for recommendation system is actually the item-based method and published from Amazon. So basically, they look at some kind of purchasing patterns, and based on what you have purchased, and based on the typical kind of, if you think about this is more like a rule, this says, okay, there are 70% of the people who actually bought a diaper, they also bought beer. And the percentage of these kind of people is actually account for 0.5% of my transactions. So basically, based on these kind of things, you can actually do a lot of things, mainly to do recommendation or do cross-sell, upsell, and all these kind of things. If we have time, we actually can talk about one surprising application of association rule mining in graph mining. So looks like a problem which is a graph, and you can actually formulate it into a association rule mining problem as well. So we will spend most of the time doing classification and predictions. So yeah, we won't talk too much about these until we come to that part. And another big part is cluster analysis. So we also call it unsupervised learning. So in this case, we don't have any ground truth labels. We don't know what's the correct label or class of the points. This is actually arguably more difficult. But even I would say that classification is relatively easy, and we already have a lot of good understanding and models to solve them. For unsupervised learning, it's still a very hard problem, and if we can really solve it well, humans are actually continuously solving these kind of problems. But if we can solve them well, we can actually do much better things than we can do nowadays. So you can think about outlier analysis as the other way around of the clustering analysis. So depending on your algorithm and the choices or definition of the outliers, sometimes some clustering algorithm will actually say, okay, these are good clusters of my customers, but these guys are actually outliers. It could be the data entry is erroneous, or it really means, okay, this group of people are kind of like not mainstream or have a very strange behavior, whatever. So outlier analysis actually is especially useful for fraud detection. In fact, I think I'm not doing that, but I think my colleagues actually are collaborating with some big companies in China. They are actually mainly dealing with different kind of fraud. Fraud could involve money, but also if you think about there is something called what's the word? I forgot it. But for example, you can actually hire people to post some message online which defame. I think there are real examples that Samsung hire many people trying to attack iPhone or whatever. I think something like that. You see, this is, you can actually see there are actually some kind of patterns there, and if you can do that, definitely it's good. Yeah, okay, so I won't spend too much time talking about, if you are interested there, you can look further, and when we go to these parts, you will have a better understanding. I just want to quickly show you some interesting stuff. So I'll put these slides online later, so probably tonight or tomorrow. Why it's not coming? Okay. Okay, I think it's back in 2016. Yeah, I think so. So it's actually have been quite a while. So basically, he runs a business, and so these are actually all about the motivation and so on and so forth. So I think his company is called Canton Line. Actually, it's featured on some startup news or whatever. So I think it's still there. So in a sense, it's quite unique in the sense that his argument that many men do not know how to dress himself. So basically, what they are doing that their original business model is that they actually hire a lot of stylists, and so basically they know your measures and your style and your desire, and they actually can customize this kind of do this kind of they can actually find maybe pants and shirts which match well and represent your style and fits your body, and they recommend to you, and they actually send it in a box, okay? And if you don't like it, you just return it, and you don't need to pay anything, okay? So, but if you like it, you just pay, okay? So that's the I don't know whether they are still running this model. So previously, they in order to do this, if you think about, they certainly don't want to send out many, different kind of recommendations, and if the customer are not interested in any of them, they don't make any money, but they actually lost money, right? And also, the customer might be really sick of, always recommending me things I don't like, or obviously not my taste, right? So basically, to them, it's very important to really to understand the need and the fit and the trend and so on and so forth. So basically, they want to do this kind of automatic recommendation system things. So I won't talk most of them. Yeah. As I said, okay. The constraint, particularly in their case, there are actually several unique things. If you think about recommendation, basically it's going to be a recommendation thing and a prediction thing. So basically, you predict, okay, this set of things will be good for the customer. There are a few interesting, unique things. First of all, the fit and the style do not always agree with each other. So the customer might want very trendy clothes, but if he is too fat or whatever, right? So it's probably not going to work very well on his body. So basically, there are some kind of conflicts there. And also the other thing that they are not recommending one thing. I think later they call it recommending a basket, because it's pretty easy. If you go to Amazon, it's easy. If you buy a book, they will actually recommend another book, whatever. But it could be related or whatever. But in their case, they really need to recommend like the complete outfit, right, including shoes or whatever. So first of all, at least some of the items should be, should catch the eyes of the customer, right? And also the whole thing should fit, right? So it's a more, if you understand what's going on, it's a more complicated kind of requirement. So that's what I said. Okay, you are not going to see. Most likely you are not going to encounter exactly the same problem as one of the existing model can solve, right? If you think about recommendation, Google does it, Amazon does it. For example, if you are news, whatever, feed engine, whatever, you need to do that. And I think if there are also dating agencies, right, they also want to do that. But each of them actually have totally different domain knowledge and requirement, and you need to adapt to these kind of things. So there are a bunch of other things, let's say code start and so on and so forth. But let me start. Okay, so this I show this because it shows the whole thing, as I said before. The first thing you need to do is really to do the pre-processing. So there are actually a lot of things where, even for them, because they are a startup, so their internal database schema evolved several times. So some of the data are stored in the older system. I think they move, maybe using MySQL or whatever, then they move on to MongoDB or whatever. So basically they need to reconcile the schemas. That's one thing. And there are a lot of missing values. They try different kind of ways to, again, you don't really need to be fancy. I mean, but basically you need to know that you need to deal with these kind of things before you can have a satisfactory outcome. And also there are a lot of inconsistent field. If I remember correctly, one thing is that maybe shoes, right? You have US 9, Australian 9, European whatever. I mean, there are even both are US. I think he told me some of the brand, okay, they are slightly narrower or longer or whatever, you know. So so if you don't consider the domain knowledge, it's easy. Okay, it's US 9. Okay, but in fact, they need to recognize. Okay, they are different. This brand's size 9 is larger than other brands, for example. So you don't mess them up. So they actually have some kind of use the domain knowledge because they do have the stylist or whatever. They really know what's going on, and they actually work out a mapping scheme so that everybody is actually on an absolute sort of like scale, so that you can really start to do any kind of job, right? And there are obviously a lot of outliers or problems. So one thing you can see is that this is the weight, okay? So some customer reports the weight is over 1,000 kilograms, right? This is obvious outlier. So some of those customers actually have more than 200 kg. It could be real, but basically they need to double check, or if it still cannot be resolved, right? Sometimes, I mean, it's just like a 1 more 0, or the decimal point is not right. Or some of them, they actually report in, what's the other, I think imperial units or whatever, right? So you really need to convert everything back into something. International state. Yeah, they also have, they also use some kind of method to automatically deal with, again, this is dealing with missing values. So for some of their old so one particular thing about the fashion business is that this type of clothes might appear very popular, let's say back 2 years ago, and then the supplier no longer make it. Okay, they have a new bunch of products. So basically, they might have purchase record on the, for example, the customer actually 2 years ago purchased these kind of things, but it's no longer there. Okay, you cannot recommend the same thing. Okay, but you need to really understand. But for I mean, what kind of preference the customer have, and for the new products, I mean the scheme might be different. Okay, previously maybe only 2 fits, regular fits and slim. Now they probably have another category, whatever. So these are also things they need to take care of. Again, he actually tried some kind of recommendation system, basically based on matrix factorization. Again, it's not a standard one, and this kind of classification based to deal with code start. So again, what they are doing that because of the, it's different from the Amazon case. As I said, I mean, you simply cannot recommend things that are out of stock or no longer made. So basically, they actually do some kind of clustering, trying to understand, okay, what are the major type of clothes, even if they are no longer there, but based on other description attributes, they can actually get some idea. So they actually try this kind of clustering algorithm. They also, So basically, based on So basically, you do have a lot of descriptions. You can see the casual 10, plain 8, stripe 17, whatever. That's their different kind of attributes. And for each of the product, you actually can find the dominant patterns. So you can see the first cluster is actually mainly the casual and the regular and the check, different kind of things. as I said, I mean, they decide, okay, they want to recommend the so-called product class instead of directly to the product ID. And once you know the class, and you can actually find the latest, I mean, products out of the fitting into this class. So they also tried, different kind of prediction algorithms. So one of the problem is that, as they said, time is biased because all the new product actually do not have enough purchase or recommendations. So they actually need to deal with the bias problem. So they come up with I think he come up with a way to decay the weight of the recommendations. So it's based on some kind of logistic functions, which we will cover as well. And finally, we also need to do some kind of smoothing. So smoothing is also a very important topic in many of the machine learning models, just to deal with missing data and trying to make the model more smooth, hence it's generalized as well. And also reducing the noise. So how to deal with a slow start. Slow start means, okay, initially you don't have, especially for new stocks, there is no purchase record. So the traditional recommendation system cannot do that well. So they actually need to, based on the profile and based on the description of the items, you actually need to do this kind of matching process. Again, they actually use Ansible classifier, and I think we'll cover Ansible classifier as well. So finally, they also incorporate the feedback. So every time if you send it, the customer can leave some kind of feedback. Maybe it doesn't fit me or whatever. So how to incorporate that into the model as well? So basically, I think let me show you the results. These are the other thing that he actually, I think that he used Node.js or whatever. So basically, and using a message queue. So basically, they really want to inject this kind of recommendation into their product. I think later they actually really do that. And to that purpose, to that end, the whole recommendation system algorithm should be fast enough. Okay, you cannot say click a button and wait for half an hour before some good recommendation results come up. So let's look at the results. So basically, they actually do this kind of things using cross-validation. So again, this is a typical machine learning technique. So trying to understand what's the predictive power. So their method finally can reach something around 70%. So for them, it's actually a pretty good thing because before they use this kind of machine-based recommendation system, it's the stylist, okay? The humans make prediction, and their feeding or their statistics around 70%. Okay, so this does not really, exceed. I mean, because this is only one semester. So, but the thing that is already on par with human being. But if you think about it, I mean, the machine can work all day long and for each new customer, right? And the turnaround time is very, very small. And finally, because it's a real business, so basically they deploy the system online and they collect some kind of statistics. So basically you can see that on average, negative feedback received is 2.36, positive is way over negative. And percentage of customer that completes, which means complete the transaction, is 84%, which again, he told me that it's very good. It sort of like means 84% of customer actually visit the website and complete some certain kind of transaction. So if you think about, that's a good conversion rate, right? It runs for about 1 week. So of course, I mean, I don't know if they are still developing the whole thing, but basically that's a real story which happens in one of my class, right, back in 2016. Okay, so I think that's all I want to show you. There is actually another slide. Again, you can see that it's actually more like, I just borrowed it from somewhere. It's a company's product. It's SaaS, I think. Yeah. So don't worry about these kind of things. I mean, we actually can. I mean, we just use the slides is pretty self-explanatory. But it's talking about one very real industrial-wise problem. It's called churn management. Okay. And I believe in Australia, not only in Australia, but in many countries, mobile phone users actually have saturated. I mean, nowadays, I mean, especially for young generation, each one, I mean, at very young age, you have a mobile phone, and it's hard to imagine someone without a mobile phone, right? So it's rather than acquiring new customers, it's very important to retain the existing customer or grab customer from other companies. Okay. So basically, you can read it by yourself, but there are actually some kind of underlines. It actually highlights the whole strategy. It's a similar story with Jai's project. Basically, first of all, you need to collect all the data and analyze it, and then understand what's the possible variables. Yeah, you can read it later. I'll put it online. Again, SAS is more like from statistical point of view. So we are more from the machine learning point of view. The variables they talk about is actually called features, typically called features in machine learning. But in statistical people, they actually call it variables, predicted variables and target variables. So you need to do some kind of feature selection and determine the model and build some kind of, they actually also use some kind of clustering, which is unsupervised learning, and also supervised learning. Okay, so again, I don't think this is a real story, but it's more like the white paper kind of thing to demonstrate, okay, you can do all these kind of things within SAS, right? That's the pitch of the sales. But basically, you can see that it's a typical process where, especially in enterprise or even in government, that if they want to deploy these kind of things, they really need to go through these kind of steps. In fact, if you ever heard about some of the funny things in data science or in general, they say that, okay, usually data scientists or whatever analysts spend 80% of time cleaning their data or transforming their data. Training a model is much more easier. So that's why don't overlook the previous part. I mean, it's very messy, it's very expensive, but it's really important for you to have a good prediction model. Okay, so that's all for today, and next week we'll start with data warehousing. Actually, introduction is not. Actually, if you have time, and I'll upload the slides there, the two supplementary ones, and I think you can try the Python thing, set up the environment, and there are two notebooks. One is on the basic things, and the other one on NumPy. You can actually start to have a.
Okay, cool. I just have a simple question.
Yeah.
First question is, I need to brush up on my math. So how would you rank each of those predictions?
Okay. I think I'll try to cover linear algebra from another angle. So it will be helpful if you already forgot how to do the matrix multiplication and.
So forgetting is a good thing.
Actually, yes,
Yeah.
yes. I mean, there is a saying that okay, what education is everything you left over after you forget everything. Because that's the thing that really inside your brain or heart or whatever, rather than just remembering okay all the formulas. So I think importance-wise, I think the first is linear algebra. The second one is actually sort-like calculus, but we're not doing sufficient. Probably mainly dealing with the derivatives or gradient. Okay. If you have multi variables, if you do the derivative on each of them, it's going to be a gradient operation. Yeah, we are going to use the Taylor expansion theory method, but again, it should be straightforward because it's just expand a function at a point to a sequence of polynomials.
Okay.
Probability theory, just very basic things, but I think yeah, I'll emphasize this, but I really want you guys to understand a distribution.
Okay.
It's hard to say without the context, but
Right.
the general idea is that you need to know that many of the learning problem is essentially to estimate a distribution. That's like the key message.
Okay.
Yeah.
Will you be presenting all of these in the maths review in a couple of weeks?
Not really. I mean, I think the math review will focus on linear algebra because that's something new. But for the other things, when we talk about specific models, we actually emphasize on that point.
Yep.
Yeah, but we are not really using too much advanced stuff. So yeah, although I mean, if you really want to go deep into machine learning, then of course, I mean, you really need to know a little bit more on the linear algebra and the calculus and so on and so forth. But yeah, for our course, it's actually should be sufficient.
Right. And what topics in this course are most relevant to natural language processing? Because I'm interested in that as well.
I don't think we are going to talk about sequence models. I mean, if you, I think the logistic regression is the most relevant one. SVM is also, yeah, our project will actually be on text as well.
Okay.
So basically, we use SVM to deal with that.
All right.
But honestly speaking, if you are interested in doing research, for example, in all of our research project, we use embedding, we use deep learning, so because they really works pretty well.
Okay.
So yeah, but I think, as I said, I mean, deep learning is actually easy to learn.
Right. Okay.
But if you don't have a solid background in traditional machine learning, you probably cannot learn it very well. So like you can program, you can whatever, try all the options, because in deep learning there are so many parameters, hyperparameters you can tune. Different architecture, whether you use dropout or not, or should I use different kind of initializations. And because most of the model training are so expensive, time consuming, so
Yeah.
you really need to have some kind of idea to try some of the things which might lead to some kind of solutions.
All right.
Yeah. Unless you are doing something everybody knows how to do it, like face recognition or whatever, you know.
Right.
Yeah.
Okay. Thanks. That's all.
I just had assessment related question.
Yeah, yeah.
Is project going to be individual or team?
For the project, if I again haven't fixed it, but
Okay.
most likely it will be a
Individual.
group based. Yeah, because honestly speaking, we don't have the manpower to
Okay.
assess. But in the past also, I mean, there are certain students requesting these kind of things. I mean, to me it doesn't matter, right? I mean, it doesn't mean okay that the project contains so much. Actually, if you think about the implementation wise or whatever, it's not so hard, especially we are using the Python libraries. But it's mainly like for the project, I think there are certain elements which are sort of like open-ended. You can design your scheme, whatever. So I think this kind of group discussion will probably help a little bit. Yeah.
And final exam will be like theory or program based?
I never test programming in
finally.
That's ridiculous. I mean, yeah. But again, it will be similar to the assignment kind of things or tutorial kind of things. Yeah.
Thank you.
Yeah, no problem.
直接拿中文说吧。就是说我之前是在那个一个创业公司做实习，然后就是说我想了解一下您的那个研究方向，就那家创业公司是做数据标注，但是他想做那个数据标注用 machine learning 这方面的东西来辅助他做数据标注。
所谓的数据标注是什么？是帮人家做 label 还是什么？
对，做 label， 做一些就是比如说图片的画框呀，画
我知道。
就这些东西。然后就是他想用一些 machine learning， 比如说用那个当时用 mask RCN 做了一下那个，就做 mask，然后效果还行，但是 就想问一下您这方面有没有相关的一些 project 可以
OK，
就是像练习或者是提升或者类似。
第一个我不做图像虽然我知道一点，但是我不是专门做图像的，所以说我不做这块。然后第二个就是说我实际上是偏 NLP 那块，偏 knowledge graph 这块。然后这块的问题在于，没有标注，就是说，比如说你说那个画图片，我知道，就是现在很多，如果你要比如带一些大点 model 的话，就会专门有这种公司，就是一张图片多少钱啊，或者什么还挺贵的，越细的
越细越精确的
对。因为你要走什么 cross sourcing 啊什么之类 ，quality 不是保证的不是很强，当然你可以用各种各样方法去做但是总的来说呢，就是我一下子倒没想得到有任何可以帮助你做数据标注的，因为我们 NLP 里面的最大问题在于没有足够标注。因为 NLP 实际上是更贴近于 semantics level。
是，然后基本上那边是做图像的，就是比如说 NLP 有个相关的，但是它首先是把人的手写体，可能说是先识别成那个字符，然后再做一些像一个
图片的话，
后期的话可能要做 NLP 的东西。
图片的话，你可以看看有谁做的，但是我不知道，你可以去问问看 Allen， 不知道他们有没有谁人做，但是 Allen 的话，可能也就是 Alex 做的好一点吧。然后 Alex 做的应该是 reinforcement， 所以说我听说 Alex 其他学生怎么样？就说 Alex 我比较熟，因为我是他 co-supervisor， 所以说对，
就是那 Alex 他的那个联系方式，
因为你当时找老板了，你当时找 Allen Blair， 就教那个 deep learning 那个 co 老师，对，好吧。OK，
你好，那个我是现在想是从事那个 data science 方面的，然后我现在有一个问题，因为我本科学的是那个 network engineering，然后现在的话，我想就是有一门课，学校有一门课就是9809101，它是那个 design and analysis algorithm， 是它的方向就是说设计。
是 Alex 教的吧？就是那个
俄国的一个老师。
对，他不是俄国，他是斯洛文尼亚或者什么
对，就是
Alex 很分区的，
对，
就是
那门课。我现在就是我觉得那门课挺好的，但是我想就是说从一出来毕业之后马上就是工作，不想读 PhD 啊什么研究类的，就是说您觉得学这门课的话有没有这个必要？就是说现在或者我就跟着听一下，或者自己自学这门课。
他教什么？
他教的就是那个design and analysis。
对，他就是我不知道，因为每个老师每年教的东西不一定一样的他教什么？
就是现在就是。
programming， 然后 hashing， 他原来叫 hashing， dynamic programming probabilistic algorithm， 然后那个像 PageRank 那种 iterative algorithm 的什么收敛啊什么之类的。
对，就是那种还有
FFT， 他教那个 Fourier transformation。Fast Fourier 或者是discrete cosine。
这个我倒忘记了，那个它是 sorting 啊什么那种。对。
就是怎么说呢？我是觉得就是那个的话，可能是做这种，你如果做 hardcore 系统或者做 performance 的话是挺有用的。而且讲穿了就是很多东西是相通的。如果比如说像，当然我不知道。比如说它那个 PageRank 的东西的话，你可以说是跟machine learning有关，因为它实际上是一个 stochastic process 的稳定态。然后，我只能说就是这很多东西就是你要看就是短期的效益和长期效益。我觉得长期角度来讲的话，肯定是有用的。就是短期如果你就像你说马上就能找工作，或者说马上就能够上手的话，data science 的话更多的是你数据库的技术有吗？
数据库稍微有一点。
有点技术，然后你machine learning知道一点，然后动手型的话，基本上就可以try了。这个东西想门槛不算太高。特别是初级的话，就是只是做一些简单的分析工作啊，或者什么之类的。说难听点，你能把 pandas 弄熟，然后能够做各种各样的这种数据清理啊，或者说 transformation 啊什么之类的，然后弄出来以后随便